Hello everyone. So now we are going to discuss about the particle physics topic. So first we are going to discuss about the introduction, then one is the classification, third topic is particle and antiparticles, fourth one is particles instability, and the fifth one is conservation laws. So now let us first talk about the introduction. So by the year 1932 we were familiar with the basic elementary particles that were the electron, proton, and photon. So we were having information only about these three particles. And next came the next particle, that is neutron, in 1932. It was discovered by Chadwick, and hence we were having information about these four particles. So these elementary particles are the building blocks of a matter, and they have some characteristic properties, and these characteristic properties we can say like they have rest mass, or they might be they don't have rest mass. Some will be having a zero electric charge, or plus one or minus one, and of course they will be having the angular momentum. So the elementary particles discovered so far, that means now we have a list of almost 200 particles. These particles are elementary in the sense that they are structureless. That means they cannot be explained as a system of other elementary particles. That means let us suppose we say a photon. We don't know how its basic structure is. That means they themselves are the elementary particles. So now let us talk about those elementary particles. So the elementary particles classification is as shown in this slide. The first one is the baryons. So baryons are further categorized into two categories, that is nucleons and hyperons. In the case of nucleons, we have protons and neutrons. In the case of hyperons, we have lambda, sigma, and omega. The next one is the leptons. That means leptons are the electron, photon, neutron, and muons. The next one is the mesons. Mesons have pions, kaons, and eta. And the last one is the antiparticles. So we are going to discuss each particle one by one. So that means what are these particles? What are its basic structure, what is its mass, what is its charge, and what is its angular momentum, and some other properties. So now let us talk about the leptons. So we are talking about these electron, photon, neutron, and muon. So first leptons. So in these leptons we are going to discuss first about the photons. We already know that photon is a charge-less particles, and its spin is 1, and it has zero rest energy, means its rest mass is 0, and hence its rest energy will also be 0. Next one is the neutrino. So we have the two characterization of neutrino, that is nu e and that is nu mu. So these charges will also be 0, and their spin is half, and neutrino also has rest energy that is equal to 0. Next we have electrons. So we have categorized here two, actually E positive is not electron, it is a positron. So E positive charge is +1 and E negative charge is -1. They also have spin half, and their rest mass energy is 0.511 MeV. The same is the case for muons. In case of muon, we also have the two particles, that is mu positive and mu negative. Both are the antiparticles of each other. So their charges are +1 and -1, and their spin is half, and of course their rest mass energy is 105 MeV. Next we have the mesons. In a meson family, we have pions, we have kaons, and we have eta. So we're talking about the pi family, that is pi positive, pi negative, and pi 0. So their charges will be 1, 0, and -1. Their spin is 0, and their rest energy is 139 and 134 MeV respectively. And the next one is the kaons. In case of a kaons, we have three particles that are actually K positive, K negative, and K 0. And the same case is with their charges and their spins and with the rest mass energy. Next one is the eta. So its charge will be 0, its spin is 0, and its rest energy is 549. So next comes the baryons. Baryons categorized into 6 categories, that is proton, neutron, lambda, sigma, and omega and psi. So proton and neutron we have charge. Proton has charge 1, spin is half. Neutron has charge 0, spin is half. Lambda has charge 0 and spin is half. Sigma has 3 particles, that is sigma positive, sigma 0, sigma negative. So it has charge plus 1, 0 and minus 1, and it has spin half. So one thing is to note here that in this case, in this family, we have a spin of half or 3 by 2, means these are the half integrals. But here in this case, here some cases have spin 1 0 0 0. So whose spin is 1 0 0 something, that will be some integral multiple. So they are known as your bosons. And the particles whose spin is a half integral multiple, so that will be the fermions. So we can also categorize here 2 types, that is bosons and fermions.